Afternoon, everybody. So we took on Challenge 7, which is commercial forecasting. A little bit of background. Sorry, microphone. Is that better? Is that even on?
Should be on, yeah.
This one, I think, is on. Right, we'll give this one a go. Commercial forecasting is, as an engineer, something that is resource intensive, inaccurate, something that I get nagged about a lot, and is generally out of date before it's published. So what we were looking to do is provide a solution that addresses that, looking at future application. So we kind of believe what we've got, hopefully, will give us some significant cost savings, will give us a lot better control over cash flow within the businesses, give us some better management for risk, and hopefully we can make the final step allow us to handle our resourcing a little bit better on the projects. So I'm going to talk tech, these two are, so over to you. That's not gone.
Okay, we're going to talk about the ML approach and how we designed it. So the training set, we've got it at the level of you basically give us a work breakdown series, a section, and the date, and then also your forecast. And then we'll tell you how likely is your forecast to differ from the actual in next month by more than 5%. And so that's the target variable we decided to go with here. And then we've also managed to engineer a range of features that we can use to inform the model after a long caffeine-fueled night of figuring out the cleaning and the joints. So some of the interesting features that have gone into this include, for example, the finish date variance of the activities in the past. How much have they been exceeding their planned dates? The number of activities currently in progress in this month. The forecast that you provided for this month and the free flow, these all influence how likely you are to differ from the actuals here. And then we're going to go on to the next step, which is the machine learning.
Yeah, so it was a very interesting model because we decided after all to try and forecast the whole thing. And just to give you a heads up to the people who haven't done much of that, but the machine learning trying to forecast the future is so much more difficult than doing any problems such as like image recognition. So here, if you achieve accuracy of let's say 95%, you go and work for the Wall Street and make lots of money. But after all, we got a challenge, and so what we did, it worked as a time series problem because you have all the activities in the past, so you have all the past, and you want to predict in the next month what is the probability that you'll be going to be off your forecast. So what we did is make this time series, so you have all the variables and observe them in the past, and we put them to a very a library that people might really like. It's called TS Fresh. So it tries thousands of different time series filters, such as tries to find mix, the mean, the max, the trend, the autocorrelation, and then finds the ones that really are predictive. And then after that, when we filtered everything to a time series, we made the problem from a time series problem to a two-dimensional problem and put it in a boosted tree. And on a test data set, although it's quite small, we got a very good area under the curve score of 48%, which is, it might be red herring because it's a small data set, but it proves the concept that you really can forecast that, and 0% is random, 48 is quite well, and 100% in Oracle. And for the future, what we can try, if we have more time, we can, if you put more data, we can try some LSTM recurrent networks, which are very good to time series as well. So I believe that this is really a problem that can be solved.
There's a couple more points about the data preparation, because this can always definitely improve the model performance further. One would be more time for the feature engineering process as well. and there's definitely more valuable nuggets in there somewhere. Weather information is intuitively quite predictive. That would need to be added externally. And also, probably, if there are any bugs you don't know about, that could be impacting performance. So more time with that, you could then resolve any possible bugs and see an increase. Next slide. So who's talking about it?
I'll talk about this quickly. The only thing we had to go out as well is turn this into a dashboard. Project managers like dashboards and visuals. It's a work in progress. I'll admit it's not quite as fast as some of the others, but we're getting there. I think there's a bit more work involved in this. As soon as we start getting the prediction out of the model, we can start to overlay this on here and see that visually. So going in the right direction. Last slide, future.
Yeah. Okay, one thing you might be wondering is why is the prediction for the difference between your forecast and the actual? Well, the truth, the ideal outcome is probably that you could have the model predict and do the forecasts for you. That would save a lot of time, automate the process of anyone even bothering to do a forecast. That could be achieved if you can improve and provide strong enough features, get it to a level of accuracy, then that's a possibility. And also, you could predict further out than 1 month as well. And then, yeah, those are the improvements that could happen. And then,
That's it.
yeah, that's it.